Hello everyone, I'm Professor Wilson Kamami. My YouTube channel is also called Professor Wilson Kamami. Here it's where we look at mathematics, where we solve mathematics both for business student, engineering student, and those science student. So today we are going to look at correlation, where we shall be looking at the relationship between variables. So kindly keep in so that we can learn mathematics and simplify mathematics together. Welcome. Welcome to the class where we said we are going to look at the correlation. And when we talk of correlation, we look at the relationship between variables. When we talk of the relationship between variables, we talk of a situation where you may have a variable x and y. So we want to look at two variables. How are they related? In this case, it's better we look at types of correlation so that we can understand types of correlation. When we talk of types of correlation, we have three types of correlation. The first one, we have positive correlation. And under positive correlation, you find that here we look at the relationship between two variables. Remember, when we have positive correlation, it means that we have directly proportional. Or what we call direct relationship. So it means that as x increases, the y also increases, and vice versa. As x decreases, also y also decreases. And if you have to represent this one in a graph, it is simple. You find that you'll be having a graph of y against x. So where if you have a dot, the line of best fit, you find that we have direct proportion. As x increases, you find that the y also increases. So in this case now, we also look at the other types of correlation. We have negative correlation. At the negative correlation, we have what we have inverse relation. What does this one mean? It means that as x increases, you find that y is decreasing. And vice versa, if x is decreasing, the value of y will be increasing. So in this case, if you have to represent this one in a graph where we have scattered points, you may find that we have to draw a line of best fit. So you find that as x increases, the value of y is decreasing. So that's what we call negative correlation. And you may find that in another type of correlation, that type of correlation is a situation where we have zero, or what we say no correlation. In this case, you may find that the choice of your variable x and y are not related. And if you have to represent this one in a graph, you may find that a graph of x and y, you may find that you may have a straight line where you find that there is no relationship between x and y. So in this case, these are the different types of correlation we have. We have positive, where you have direct proportion, a direct relation. Negative correlation, we have inverse relation, and you may find a situation that the choice of your variable, there is no relationship between x and y. Remember, the x and y may be representing maybe profit or sales, maybe x is sales, and y may be representing profit. So you want to look at how sales and profit are related. Does it mean when you sell more, you make more profit, or does it mean when you sell more, you make less profit? Or you find that sales and profit are not related. So those are different types of correlation. Another thing is that when we are looking at the value of correlation, the correlation we said we use small r, although we can also use capital R, where we look at the correlation when we are calculating the correlation coefficient. And you find that the value of R will be between -1 and 1. So whenever you are calculating correlation coefficient, you find that the value of R is between -1 and 1. And in this case, you find that if I have to use my graph here, you find that you had drawn the point of, it was a scattered graph. The more the points are related or are close to our line of best fit, that's how close they are to 1 or to -1. In this case, if you have like this one, you find that all points are in our point, we don't have scattered that are missing. In this point, you find that you may find R is 1. The same case here, if we have all points are on our line, you find that the R in this time, the correlation at this time will be -1. So I want you to take note on that. Now, how do we calculate correlation? Correlation, we say correlation is n summation of xy minus summation of x summation of y all over. The denominator is at the square root sign where we say it is n summation of x squared minus summation of x, then times n summation of y squared minus summation of y, where is squared summation of y. Everything under the denominator is at the square root sign. So in this case, you find that n is the number of data we have. X, remember x in my case was sales. So the summation of x is summation of the sales based on your data. And y, remember we had assumed it is our profit. So if we are to calculate correlation coefficient, R is our correlation coefficient, so that the value you get of R will determine if we have positive or negative correlation. And if I was to represent this one in a small, so where we have a 0 here remember we said R is between -1 and 1. Here you find that this side we have negative correlation, this side we have positive correlation. So, and if you are to divide this side into 2, maybe by -0.5 here and 0.5 here, you find that here we have what we call weak, here we have strong. Weak, strong. You may decide also to divide this one into 3 parts, maybe where you have strong, moderate, and weak. So in this case, what will happen? The value of you get of R, assume R is -0.29. You find that this is a weak negative correlation. So you find it is a weak negative. Based on this smaller illustration, you can be able to find that if you get the value is 0.29 positive, you say we have weak positive correlation. And if you based on your variable, you can be able to explain that the relationship between sales and profit is weak, but they are directly we have what we call direct relation, that increase in sales lead to increase in profit, but you may find it is weak. If we have strong like 0.78, assume R is 0.78, we say that we have a strong positive correlation of 0.78. Let's now look at how do we calculate correlation coefficients. We have said if we are to look at the correlation, we say this equals to n summation of xy minus summation of x summation of y all over everything at the denominator is at the square. So it is n summation of x squared minus summation of x, then we have n summation of y squared minus summation of y squared. And I want to pay attention on this one and this one. You find that this is the summation of x. After getting the summation of x, that's when you square. But the difference with this one is the summation of x squared. Maybe we can take an example. We can take a very simple example where we look at how do we calculate the correlation. And in this case, you find that I'll give you just a simple example to illustrate how do we get. Let's assume we have x, which in our case we said it will be sales, unit sales, and we have profit, which we said we represent with our variable y. Assume we have 1, 3, 5, 7, 9, and 10. So we have, in that case, we have we are comparing using 6 data, 7, 9, and 12, and also 12 here. So we want to calculate the correlation. So it means that I will create a small table this way so that we can understand where x is 1, 3, 5, 7, and 9. We have y, where we have 2, 4, 7, 9, 12. I had 9 and I had 10, sorry. So here we have 12, 12. So we can cancel that. So in that case, we have x. So it means that here I can get the summation of x, total of x. I'll take 1 plus 3 plus 5 plus 7 plus 9 plus 10. And when I get the summation of that one, I'll get it is 35. I need to get the summation of y. It is 2, 4, 7, 9, 12, 12. When you add that one, you get that the summation of y is 46. Based on my my equation, I need xy. Xy is simple, is a product of x and y. So it will be 1 times 2, 2. 3 times 4, I'll get 12. 5 times 7, I'll get 35. 7 times 9, I'll get 63. 9 times 12, I'll get 108. 10 times 12, I get 120. So that the summation of xy, it is the total of xy column. When I get the summation of this one, I'll get 340. So in this case, I need x squared. So in this case, remember, I had the data of x, so I need to square 1, it will be 1. I square 3, I'll get it is 9. I square 5, I'll get it is 25. I square 7, I'll get it is 49. I square 9 again, it will be 81. I square 10, it will be 100. So that the summation of x squared, what will be the summation of x squared? 265. Again, I need y squared. So it means that I need to square my y one by one. 2, it will be 4. Square of 2 is 4. Square of 4 is 16. Square of 7 is 49. Square of 9 is 81. Square of 12 is 144. And again, square of 12, it will be 144. And when we add this one now, what we call the summation of y squared, we will get that is 438. So with that one now, we can be able to use our formula where R will be n. What is n? N is based on the data we are comparing. Remember here we have been given the data for 1, 2, 3, 4, 5, 6. So in that case, my n, I can write it here, n is equals to 6. I want you to pay attention. We are comparing data of 6. When you sell 1 unit, you get a profit of 2. When you sell 3 units, you get a profit of 4. So we are comparing using 6 data. So that is my n. 1, 2, 3, 4, 5, 6. So that becomes my n. So if I was to replace on my formula here, my n will be 6 times, what is the summation of xy? Total of xy here, we got it is 340. Minus summation of x, it was 35. The summation of y was 46, so you multiply with 46 all over. Remember we said everything you made in the denominator is under the square root. So n again is 6 times summation of x squared. I want this one you pay attention that the summation of x squared, it is the total of x squared column, which is 265, minus what is the summation here? Summation of x. It is this summation of x, which is 35, that we are squaring. This is key, that it is summation of x that we are squaring. The same case will happen with y. N is 6, and n is 6, and the summation of y squared here is 438, minus, again, here we are using the summation of y, which is 46, that we are squaring. And when you solve this one, you find that when you get this one, it is 2040 minus 1610 all over 6 times 265, you get it is 1590, of which you can confirm. That's why we are here, we are simplifying mathematics together. So 6 times this one, you will get it is 2628, minus when you get 46 squared, you will find it is 2116. And if you solve numerator, you get it is 430, the difference, all over. When you solve here this part, you will get it is 365 times. Now when you solve this one, you get it is 512. And when you solve that one, you get is 430 all over. Now the product of this and this one, you get it is 186,880. And now when you solve that one, you get It is 430 all over the square root of this one. I think is get 432.296165. And when you solve that one, you can be able to get that one. You get 0.9 something, which is our R. So you can as well confirm the values, which I know you will get 0.9 something. So you can proceed. So that's how we calculate correlation coefficient. Our R. That's how we get that. And in this case, if we are to use the illustration I showed, you'll find that your 0.9 is being found here, because if here is 0, 0.5, and here it's 1, you find that 0.9 we get. So we can be able to explain that we have strong positive correlation. That's how we calculate the correlation. And don't forget that when we talk of correlation, either in research or in anything, we say it is the relationship between two variables. We are looking at how are those two variables related. So with that simple example, I will call it example 1. Maybe I can bring another illustration of example 2 where I'll have a lot of, maybe I will explain further. But the formula of how we calculate correlation coefficient is that way. And it is simple for you to distinguish between when we are talking of summation of x squared and when we talk of summation of x into bracket squared. The same case applies with this one when we talk of summation of y squared and when we talk of summation of y into bracket squared. So, okay, before we close, I want to look at the summary of what we have covered today. We said we are looking at the correlation. When you hear the word correlation, you automatically it's the relationship between two variables. So in that case, in our case, we are looking at the relationship between sales and profit, x and y, where x is representing sales and y is profit. And we looked at the types of correlation. We said we have 3 types of correlation. We have positive correlation, where we said we have direct relationship. When we talk of direct relationship, it means that if x is increasing, also y is increasing. Maybe you may look at the age and wealth. Maybe the more you become old, the more you become wealthier. Maybe that's what we call direct proportional. Well, then we have a negative correlation where we have inverse relation. And when we look at the inverse relationship, is where one is increasing, the other one is decreasing. Maybe the more you age, the poorer you become. Or you find that we have negative relationship. So that's where negative correlation. But you may find the choice of your variables are not related. So in that case, we will be having what we call zero correlation or no correlation. We said when you are calculating the correlation coefficient, we say that our R is between -1 and 1. So the closer you are to the -1 and 1, that's where how strong it is. I explained with this small illustration that if we are to divide from -1 to 1 with the 0 obvious, here we have negative correlation, here we have positive correlation. And if you are to divide negative into 2, you can say at this level you have weak negative correlation. Here we have strong. The same case with the positive. And I gave an assumption that if it is -0.29, we have weak negative correlation. If it is 0.78, remember this is positive, so we have strong, because it's found here, strong positive correlation. Then I was able to say that how do we calculate correlation coefficient? I said we use this formula. And we are able to look at the example, and I said it is clear we'll be able to look at what is the difference between summation of x squared and summation of x. Summation of x squared and summation of x into bracket squared. And I gave an example of that one that I said summation of x squared, it is the total of x squared column. But the summation of x, you first of all get the summation of x, then you square it, which is 35 in this case squared. And we did that example. And we got our correlation coefficient, which was 0.9, which we will see that we have a strong positive correlation. So in simple, it means that the relationship between sales and profit is positive, and it's a strong relationship that increase in sales. The more you make sales, the more you make profit. So with that simple example, thank you for watching. Continue subscribing. I want to encourage you so that you watch the next video where we shall look at the correlation example 2. And from there, we can be able to include, to look at regression and look at how the correlation and regression are related. And then we can be able to see how we can apply the issue of correlation and regression when it comes to our research. Thank you.